Hello friends, welcome to my channel. I hope all of you are fine at your place. So tomorrow will be Krishna Janmashtami, so let me wish you in advance Happy Krishna Janmashtami to all my viewers and friends. So as you all know, in this channel I try to give you the solutions of the questions which were asked in previous year CSIR NET and GATE Physics exam. So today we will be discussing a question which were asked in NET exam in June 2012. Let us read the question first and try to understand the output O of the given circuit in cases 1 and 2 are respectively. So now here case 1 and case 2 are given, and this is the circuit diagram. It's logic gates basically. Case 1 is where A and B both are 1, C and D both 0, E and F both 1, and G is 0. Case 2 is A and B both 0, C and D both 0, E and F both 0, G is 1. And now 4 options are given. Out of these 4 options we have to choose which one is the correct one. So from looking at the question we can make a guess that it is a question from the topic digital electronics. So let us see. First pay attention to the circuit diagram here. This is the arrangement of gates here, and we can name these are the inputs A, B, C, D, E, F and G, and we have just written the gate number. This is gate number 1, which is the NAND gate. Gate number 1 is NAND gate. Its output will be Y2. Y2 will be given as Y1 prime, Y1 bar, sorry. It will be A and B bar because it's a NOT gate in front of the AND gate, so it becomes NAND gate, and Boolean expression for this will be A and B whole bar. Now gate number 2 is a AND gate, so AND gate is output will be Y3. This we have chosen Y1, Y2, Y3, all these we have chosen. In the question it was just the circuit diagram. We have given them the numbers 1, 2, 3, 4 for our ease of understanding, and also we have given the outputs so that we can easily get the final output. Here its output is Y3, and Y3 will be given as C and D. Now gate number 3 is OR gate. So OR gate will be given by its output is Y4. So Y4 is given as Y2 plus Y2 or Y3. This is the Boolean expression for this OR gate. Gate number 4 is again AND gate, and its output is Y5, and we can express Y5 in terms of Boolean algebra as Y5 equal to Y4 and E. Y4, this is the Y4 input, and next input is other input is E. Now next gate is our OR gate. Gate number 5 is OR gate. Its output is Y6, and Y6 can be written as Y5 or F. This is the Boolean expression. One input is Y5, other is F. And the last gate will be our NAND gate. And NAND gate output will be Y8, which is nothing but Y7 bar, which is equal to Y6, G, Y6 and G with whole bar. So these are basically the 6 gates. First one is NAND gate, second is AND gate, third is OR gate, fourth is AND gate, then OR gate, then NAND gate, and then final output Y8, which according to question is O. So we have just given them the names. Now the Boolean expression for the final output is O, that is Y8. According to us, Y8 will be this. Boolean expression will be nothing like Y8, and Y8 is given by Y6 G whole bar. So in order to get Boolean expression, we will replace the values of these variables that we have assumed Y6. So Y6 will be nothing but this one, Y5 plus F, and here we will replace Y5 with its value Y4 and E, and then Y4 will be replaced by Y2 or Y3, then Y2 and Y3 will be replaced by their respective Boolean expressions. So putting them one by one and carefully solving them, we will get the final output for the expression for the output O, which is Y8, will be AB bar plus CD bracket with AND operation with E plus or operation with F, again then G, and then whole bar. So this will be our final expression for the output O. Now in order to get the output O, what will be our output? Because the question is option are given in 0 and 1. So we have to obtain the final output across this gate y8, this output. So what we will do is we will just write down the truth table for each of these gates, and according to question A and B, first gate will be NAND gate. Our inputs are A, B. Output will be y1 for AND gate, and it is an AND with NOT, which is NAND. So y2 will be y1 bar. So first case is where A and B are both 1. So y1 will be 1, y2 is 0. Second case is where A and B both 0, y1 is 1 and y2 is 1. Similarly, we will draw the truth table for both the cases as given in the question. Again, C and D are both given as 0. With AND operation, y3 will be, its output is y3, which will be given as 0. Now third gate is OR gate, and the operations here will be 0 0 with 0 and 1 0 with output y4, output is 1. Again, fourth gate is AND gate. Here AND gate is one input is y4, other input is E, and the possible values of y4 are 0 and 1. Again, possible values of E are 0 and 1, because in question what we can say here that E can take both 1 and 0 as its value. So we have taken as both 0 and 1 and we have performed AND operation, and after that the output y5 will be 0 0 0 1. Now next gate is OR gate. Here y5 can take both the values 0 and 1, and F can also take both the values 0 and 1 according to question. So we will perform OR operation, and in the truth table we will obtain the values 0 1 1 and 1. Now the last gate will be a NAND gate. A NAND gate, since y6 can take both 0 and 1 values, and G, see, look here, G can also take both 0 and 1 values. In first case it will be 0, second case 1. So for the combined case, generally we have put down all the possible values in the truth table, and that will be 0 and 1. After performing AND operation we will get this, and just we reverse it because the NOT gate, and it is a NAND operation, and we will get y8 as 1 1 1 and 0. Now these are the truth table with all the possible values according to the question. Now we will final output that we will obtain is, final output will be, we will take the case one by one. First case will be where A comma B 1, so y1 is 1, y2 is 0. Second, then C comma D here is 0 and 0, so y3 will be 0. So here y2 we will take 0 because for case 1, and y3 we will take 0. So y4 for around the output along the third gate, that is OR gate, will be 0. Now y4 we have to take it as 0, and E in first case will be 1. So the output will be across this part, this input line, y4 0 E1, so output y5 will be 0. Now we have to remember this, y5 will be 0, and again in first case F is 1, so 0 and 1, so we will obtain this combination 0 with F1, we will get output y6 as 1. Now when y6 is 1, this input will go into the, this output will go into the input of the next NAND gate. So we have to take y6 with 1 and G with 0, because it is given in question case 1 G should be 0, so y6 1 G 0, we will get y7 0 and y8, which is output for the final output of the NAND gate will be 1. So this we obtain as the first case. As you can see that I have marked case 1 and case 2 differently. Case 1 is with tick and case 2 is with the star. See, case 1 with tick and case 2 is in star, and this marking will help me in taking out and in choosing the proper combinations of inputs and outputs from the truth table, because it contains two cases. So for first case our output will be 1. Now for second case, what will be the final output for second case? In second case A and B are now changed, both 0, so 0 0, y1 is 1, y1 is 0, y2 is 1. We have to remember this, y2 is 1 now. Now C and D again in second case both are 0, so y3 will be 0. Now its output of second gate goes to the input to the third gate OR gate, which is, so Here y3 we have to choose 0 and y2 we have to choose as 1. So y2 1, y3 0. This will give us the final output y4 as 1. Now we have to remember this input will go into the output of 4. This output will goes into the input of the fourth gate, which is AND. So y4 will be here 1. This and E in second case is taken 0. So this combination we will take. Y5 we obtain here as 0. Now this output goes into the input of fifth gate. See here, this output 0 and F in second case is again 0 according to question. So 0 0, this will give output for the OR gate as 0. Now this output goes into the input of the next NAND gate. We have to remember this y6 we have to choose 0 and G here we will take it as 1 because it is given in the question. In case 2 G is 1 we have to take, so we will choose this combination of inputs and outputs. Here y7 will be 0 and inverse of this, because NAND gate it will be 1, so final output becomes 1. So the final output y8 which is 0 is given by, for case 1 it is 1 and for case 2 again it is 1. So this we have to do, and by looking carefully at the proper combination of inputs and outputs we can obtain this result 1 comma 1. So the correct option is D. Let us see, correct option is D, 1 comma 1. So I hope friends you have understood the solution of this question. Thank you.